lecture. Today we'll talk about the chapter 11. I will talk about the first half of this chapter, and Professor Lee will continue this part at Thursday. So, chapter 11 is the file system interface. So, for the multi-user, we don't, usually recognize OS as our CPU or hard disk drive, because when we usually use the operating system, we just open file, creating files, and they run the executable files like this. So for the normal users, the file system is the most visible aspect of the operating system. So from this chapter, we will know the file concept, test method, disk and directory structure, and not data structure, file system mounting, file sharing, and protection. Protection is like you have so many counts. The administrator count have the write or read authority, but when you just log into the guest account, you just only have the read authorized. So from this chapter, you will know how to explain the function of file system, describe the interface of the file system, and also discuss file system design trade-offs and explore file system protection. So the file structure, we'll talk about later in the middle of this lecture. So first, the file was stored in the contiguous logic address space, like the hard disk drive or the memory. So how can we differ different type of files? So usually we use two ways, depends on the data the file is stored. So like a TXT file or the doc file, Word file, we use the character data, or some file will combine of binary or numeric files, so it can differ different type of file by their data type. But also we can differ from the different file, depends on their program they are using. It's like the exe is a runnable executable file, or the doc file use the Word file, so it's different program open it. And also the file is stored in the file system. The file system consists of two distinct parts. One is a collection of files, so we talk about file concept. The other is directory structure, which organize and provide the information of all the files. So the contents was defined by the file creator. So it's like when we create this PDF file, the Adobe Reader will decide which contents it will create it. So you will see a lot of example, like texts, a sequence of character organized into lines, like TXT file source file, a sequence of subroutines and functions, like the C programs, the source code, and object file, a sequence of bytes organized into blocks, understandable by the system link, or executable file, like the extension is exe. It's a series of code sections, so we can run in the operating system. So next is file attributes. So we have a lot of attributes of files, like name, like people, we also have name, so it's for the human readable form. So also the file has identifier, so as we all know, in different directory we can create the same the file with same name. So how can we identify that? So we use the identifier. So each file have their unique identifier, like their ID is a unique tag number. Also, it has types. Type is just what kind of operation is equal to what kind of program you use. It's like an extension. You can see different type by their extension. Also, the file has their location. It's a pointer to their file location on devices. It's their address. Also their size, how big the file is, current file size. If we change it, the size will be changed. Also the protection, as I just talked about, controls who can read, writing, and executing. So administration account has the highest level of the control, so it can read, write, or change some system settings. Also include time, data, and user identification, like the first time we created, the last time we modified it. Yes, like that. Also, there's a lot of another information will be stored in the directory structure and will be also stored on the desk. Also, some files will store the checksum of the file in the file attributes. These informations are kept in the directory structure. Okay, this is an example of the file attributes in the Mac. Let's see. This is the kind we'll use document to open this file. It has size, its location, the create date, the modify date. This is label is which only OS has. You can create different labels and you can find the file easily. And has more information, last date opened, and extension is TEX. This is related to the kind, which program you will use. Also you can see which you can choose what program you want to use to open it. So it also has the protection, which kind of user account has, which also a right to do it too. So usually we always do when we use computer, we create like PPT file or Word file. So what kind of operation we usually do? We can summarize it into 6 very basic operations. So file first is an abstract data type. So first we'll talk about create. Create is creating a file. So you will have 2 steps. First, you will find a space in the desk, so you can create a file. Second is an entry for the new file, and that should be made in the directory. Also, we have another 2 very common used operation: write and read. When we create it, we want to write something in the file, so we should use the write operation. So at this point, we will have a write pointer. So it will follow the address of the location of the file. So when you write something, the write pointer will update automatically whenever write occurs. So the reader is the same. The reader also has a reader pointer. So a little difference is, usually we will read and write in the same time when we modify one file. So at this time we will have a name called current live position pointer. It's the same position of the read pointer and the write pointer, so we combine it together into just one single pointer. It's called current file position pointer. Usually we use it when we write the file. So when we read it, we just need the read pointer because we need to modify it. Okay, this fourth operation is the reposition. So reposition has to use the pointer I just talked about, the current file position pointer. So when you want to modify the data not from the current pointer position, you want to change it. So you will use the reposition operation. So it is also sleep method. Another two is kind of like delete and truncate. It's a little bit different from delete and truncate. Delete is like delete all the contents, also the file attributes. So you will find the directory and find the entry and release all the memory or the file space in the hard disk drive, so it can be reused by another file. Also, it will erase all the directory entry. So truncate is a little bit different. It's just delete all the contents of the file, but the file attributes like the name, identifier, type, location, protection will be still stored in the file location, except the size. Because you delete all the content, the size will be 0. So it's a little different between the delete function and the truncate operations. So when we do these kind of operations, we will use the open and close kind of behavior. So open is obvious search the directory structure on the disk, so we can load it onto the memory. So close is the opposite way. You move the current entry from the memory to the hard disk drive. So we'll talk about the open files, how this work. So when we open the file, we will have the system will find the entry of this file, and also it will hold the entry and store it in the open file table. This track of the open files. So each process will open maybe many files. So it will have a lot of entries. So this one table named open file table will store all the entries. Also, it has a file pointer pointing to the last read location per process that has the file open. So it's similar like I just talked about the position pointer. So typically the operating system has 2 levels of the table to store the entries of the open file. So the lower part is per process table. So the per process table will contain all the file each process open the entry. There's another high level table is called system-wide table. So each time the process open one file, it will store the entry of this file. Also, it will turn into a point to the system-wide table. So the system-wide table have all the entries of the process of the entry. So it's like when the process open one entry, this entry will become a pointer and go to the system-wide table. And if another process open the same file, it will open with different entry, but the pointer to the file will be same. So when another process open the same file, it will submit this to the system-wide table. The system-wide table will know the 2 process was access the same open file. So we have a file open account in the system-wide table. So it shows the count of name and times a file is open. So maybe the file open count will be more than 1, it will be 2 or 3. It shows this file was opened by 3, it means 3 process. So it means 3 process are holding this file. Also, we'll see the file open account. If you open a file, the open method, open behavior will run once. So if you close, it will use the close method, and the file open account will decrease 1. So if the one process one entry of the open file will decrease to 0, so it means no process was holding this file, so this file will be closed. So next we'll talk about the open file locking. It's very similar to the lock and to read the write locks. So share lock, so similar to the read lock. So you will have so many processes to access the same data at the same time. Exclusive lock is similar to the write lock. So you can't access this lock to get this lock if another process is holding this lock, especially when you write something. So you have to wait the last process to release that lock, then you get the lock, then you can write. So it's called exclusive lock. So this will be mediate access to the file. Also, they have a different type of the locking. It's called the mandatory and advisory. So mandatory is obvious, access is denied dependent on locks held and request. So it's like in the system which just only supports not cooperation version. It's like you just can only do one behavior at one time. So this is called a mandatory. So on the other hand, there's another way you can call it the advisory locking. It's really it's a little bit trick. So it's process can find the status of locks and decide what to do. So it's will be supported in the cooperation system. It's like you can do two processes can access the data at the same time, like the write. So when you use the advisory locking, it will be like when a write lock, when a process have the write lock of this one file, the other process want to write this file also, he will find the status of this lock first, and he can choose wait to the end when the last process to release lock, or you can access the data at the same time. At the same time, you can also write. So it's a little bit tricky. So the Windows OS was using the mandatory locking. It's just one time one process. But the Unix will use the advisory locking. So maybe two processes can write the same file at the same time. And the behavior will depend on the program. Like if a program said I will wait to the former process to release the lock, I will wait. If the program said even if there's a lock you also want to write, this you can write. So it's called advisory locking. This is file locking example using Java API. So first we'll get the definition of this lock method. We will request the first obtaining the file channel of the file, so we'll get the channel of the file. So we have a lock method. Lock method is from the file lock type, and the first parameter is the beginning of the position of the file you want to lock, and the second parameter is the end position of the position of the file you want to lock. Third is share the Boolean data, and at this time if you set this share parameter to false, it means exclusive lock. If it's it will be true, it will be the shared lock. So let's go back to the code. So we will import these libraries, and we will declare two variables, Boolean type, exclusive equals false. So it means if you using the lock method, it will be exclusive lock. So Boolean shared is equals true. So we create this file lock show exclusive to equal to none. So first we will get the file. So new random text file file name, and we want to read and write. To get the, then we get the channel of the file. So we use the channel to get the channel of this file. This file is from here, file text.txt. So we will now lock the first half of the file. So exclusive lock. It's here, declare here, equal to the channels and the lock from first half. So start from 0 and half of the file. So the file is graph, so we will get less of the file, then divide 2. So this is the half the position of this file. So we will set exclusive lock. So exclusive here is false. So right here false means exclusive lock. So now we modify the data. So you can type the data code here, and after you modify the data, you release the lock. So you use exclusive lock release. Also, you can create a shared lock. It's the same, just the different parameter, because we want to lock the second half of the file. So we start from second half and to the end, and is the length of the file. So the parameter, third parameter is shared is true. So when it's true, it will be the shared lock. So we can do whatever we want here, and after we hit it, so we will release the lock. So finally, we will release all the lock. This is you're using Java API to do a file locking or something. This is file types. This we talk about the executable like exe, com, bin, or maybe in Mac OS is dmg. An object file extension is obj. It's compiled language. Source code like C, Java, has its source code in different languages. The patch file extension BAT is command, so also you can run it. Text file extension like txt, doc, Word file. It will include text data documents. Word processor like DOC also use as a word processor. Library extensions lab DLL is normally used. Print or view file type, use Photoshop, will extension will be PS, and Adobe will be PDF. JPEG will be JPG. It's a view file. Also have archive file. It's like zip and tar. It's a compressed file extension. Also have new multimedia file. Have different extension like Mag, MOV, ARM, MP3, AVI, or TMV like that. This is a Unix system. When you want to know the file types, you will type. So first you will know how what's file in your directory. Use list. Then you can use file command to see which this file, which program it will use open. It will use this command text, ask a text directory. Okay, file structure. File structure is a sequence of words and types. It can be seen the different two types is single record structure or complex structure. Simple record structure like lines, so have each line is a structure. Also have a fixed length. Fixed length is like a column, so the column will have the fixed length. So if you don't have the long enough to fix this length, the remaining part will be empty, already none. So it's called a fixed length. It's kind of like when you transmit data. It will be divided into block. So it's kind of fixed length. In the last block, it will not fulfill all the block. So it's like fixed length. The variable length is like depends on the variable length. So it will be different. Also have a complex structure. It's like the formatted document or relocatable load file. And the operating system and the program will decide which type of the structure we will use. It's like Word, like we will use MS Word, we will use a format, we'll create a complex structure with a format document, or we will use the Notepad, we will just create a simple report structure with lines. So this depends on the program. Also, operating system is like when you open when you boot the operating system, you will create a log file. So operating system will decide the log file will be simple record structure or complex structure. This is access. So access method can easily into two parts. It's a sequential access. So we have just three more behavior here. So yeah, let's see. We have a current position here. So it's like when that I just talked about the current live position pointer. It's like here. So when you using the reposition operation, this current position will be moved to the forward or backward. So you can go to the new location, so you won't read all that. So at here in this sequential access, the data will be stored in order. So it's like was stored in sequential order. So we will use the method or operation like this, read next. So because it's stored sequentially, so we will just read next until the end of the file. So write it's the same, so we will write next. And reset where we'll get the we'll make the current position to the 0 when we use the reset. So at here sequential access the data will be stored sequentially 1, 2, 3, 4, 5 to the end. So when you read the file, it will just start from one point, then read sequentially to the end. There's another, it's called direct access. Direct access is a file will be divided into many blocks. So the block have a fixed length of logical records. So it's different from the sequential access. The data will be stored randomly on the disk drive. So you have to know the address of the block. So when we use this direct access, you will see we use different operation or different method. You will see we will read n. The n means the block number. So maybe we when we save a file, it will be divided into two blocks. The block number may be 1, another will be 100. These two blocks will be stored into different part of the disk drive. So when you read it, you will read the block name. You will find the block here, so you have to know the block number. So at here, when you read the file using direct access, you will read the file with their block number. So if you want to read another, maybe this two parts, the another one is 100, block number is 100, so you will go to the next. The next will be the pointer to the next block. So normally we will use read the block, write block, and position to the block. Also, when you want to read the next, you will use not like sequential access. We just use read next. We will read the first block first, then go to read next, then find another block, then read the block again, then like read write is also. So relative block number allow us to decide where the file should be placed, so it will be randomly stored. So it will have some allocation problems. So we will see that in the chapter 12. So this is a simulation of sequential access on direct access. So we just talk about sequential. We use readmax, writemax, and the reset. So at here we will use, this is the address, it's like the block. So we will simulate the sequential on the directory access. So when we reset, the current position will be 0. So the position will go to the 0. So when we use use this direct access to simulate this sequential, next means the address will, because in the sequential access the address is sequentially in order. So when you use direct access, we will read this address, then address plus 1. So we will get next address. So in this way we can simulate the sequential access. Write is the same. So there's another access methods. So these methods are based on the major concept of the index. So you will keep the index in the memory too, because index is fast for you to retrieve. And then, but if it's too large, maybe you will use 2 levels of index. So it's an index of index. So we see the second level of index will in the memory is faster to retrieve, and the lower level index will on the disk. So this all the method is for fast retrieval. So the IBM index sequential access method is like, it has a small mass index, is kind of a higher level index, and then the second, then points to the disk blocks of secondary index. So we didn't directly find the data with the masked index. You will find another address, this address, find another secondary index. The secondary index will show where the actual data is located. So file kept stored on FileT. This is not done by the operating system. This has a 2-level index. So when we use index, we will, the requirement is the data was sorted. In this way, it's alphabetically sorted, because when we retrieve the index, normally we will use the binary search. So binary search, the requirements of the binary search is this data should be sorted first. So we will find the index, and here is the, it's kind of master index first. So we will find it's not directly data, it will store the logical record of the number. So now you find the number of the logic record, then we find the relative file. This is a directory structure, and this structure, just we talked about last lecture, can be divided into partition. Discovery can be RAID, so it can protection the data, and the data this can be used as raw data without file system. The partition, also known as slice, so it's like a partition, like you divided the disk into several parts. This is a typical file system organization. Disks 1, they have just 2 partition. At this point, 2 disks will be combined to 1 partition. So it's kind of different file system. So the next in the chat, the Professor Lee will give you guys lecture. So yeah, here's today's lecture.